Okay, so in this video I'm gonna show you how to create a simple project using the Arduino UNO and the 128 by 64 pixel OLED display connected using either the SPI or I2C connection, and the result will be an animated gauge, something like this. In the next video I will show you how to display some real data, but this video is all about drawing this gauge. And as you can probably tell by the custom PCB, this video is sponsored by PCBWay. And if you use the link down in the description, you can get 10 PCBs for free, only paying for shipping, which I think is a pretty good deal. On top of that, you can choose from quite a few different colors, and I really like this white one. With all that said, if you want to follow this video and this tutorial, it's perfectly fine to just use breadboard or this prototyping shield that snaps to Arduino UNO and includes a very small breadboard. So let's get started with the project, and we will start by creating the graphics. We will be using Photopea, which is a free online image editor, and our goal today is to create something like this or perhaps something like that. So let's get started by creating a new document. So File, New, and create a new document in the size of 128 by 64 pixels and change the background color to be black. Hit the Create button and we have a blank new document. So I will zoom in a little bit, and we want to start with this circle. For that I will right click this button which says rectangle and select ellipse. Then I will hit the Shift button on my keyboard to make sure we are not drawing ellipse but rather the circle, and I will draw the circle in the size of 66 by 66 pixels, which is the size I was using, like this. If you don't see anything, that's because the fill is set to black, so I will change the fill to white and make sure that the stroke is set to no stroke. Then I will create a second circle, but this time 1 pixel smaller, so it will be 64 by 64 pixels. Now if you don't have this properly centered, you can move the shape by hitting the spacebar on the keyboard while you are drawing, so something like this. And it was created in the same layer, but it's just united. So I will click this path selection tool, select this path and make sure that the path 2 is set to subtract from the first path. So this is the outline for our gauge. Let's continue with the big tick marks. So you can see that the first tick mark started at position 45 degrees and it takes a span of 270 degrees until the last tick mark, and I have 8 different tick marks. Let's draw the first tick mark by zooming in a little bit like that and draw a new rectangle, which is this one, in the size of 1 by 4 pixels. Now this is a separate layer, I want to merge this together, so I'll select both layers and select layer, merge layers, or Ctrl E on my keyboard, zoom out. And I want to rotate this first layer by 145 degrees. So I will press Ctrl Alt T or select Edit Free Transform, and I will enter the angle of minus 135 degrees. Hit the Enter key and that will be our first tick mark. Before I move to creating other tick marks, I will create a copy of this layer by either hitting Ctrl J or just dragging this layer over this new layer icon to make sure I have a copy, because I will need it very soon. And I will create one more copy and rotate it by a certain number of degrees. Now to get this number I will just calculate it using the calculator tool. Again, I know that the span is 270 degrees and I want to create 7 different tick marks. So this gives us a rotation angle of 38 something. So I'll just copy this number and place it in here and hit the Enter key. And I will do it a few more times. So Ctrl J to create a copy, Ctrl Alt T to transform it, and just paste this value one more time. And I will just continue like this, Ctrl J and transform and paste the value and maybe speed up this a little bit. After that I will select all the tick mark layers and merge those together, so layer, merge layers. I want to get rid of those circles, so I will zoom in maybe a little bit even more. Select the path selection tool and draw the selection rectangle like that, so I will select those circles, hopefully. Okay, I have those selected, hit the delete key, and now I only have the tick marks, and the circle should be in the other layer, of course, together with one of the tick marks, which I don't need, so I can delete this tick mark as well. So now I have the circle and I also have the tick marks. Obviously we are only looking to get 1-bit image, and this is using a grayscale values. So for that I will create a new effect, so click this icon and add the threshold effect, like so, and you can see that we are getting 1-bit image, but maybe it's not perfect. So for example here some pixel is missing and here we have double pixels. So what we want to do, we want to slightly adjust what we get from the threshold effect. For that I will create a new layer, so clicking this new layer icon, then select the pencil tool, make sure that the size is set to 1 pixel only, and click this icon which will set the foreground color to black and background color to white, and we can start making some small adjustments. So I'll zoom in a little bit more and maybe get rid of this part by just drawing the black values over those, maybe get rid of those pixels, and then click the X key on my keyboard, or just clicking this small icon to switch the colors from black to white or white to black. So now I have white color, so I'll just continue with this tick mark, get rid of this extra pixel, and this extra pixel, and make this 4 pixel white. Again, switching between the black and white by clicking the X key on my keyboard. Here I probably want to have it maybe a little bit bigger, like so. Get rid of this pixel, this pixel, this pixel. Here is one missing. This is 4 pixels wide, which is nice, and this is fine. So this gauge is mirrored, so I don't really need to work on the whole gauge. I only need to work on 1/2. Then what I can do is I can just select this piece of the gauge, hit the Ctrl-Shift-C on my keyboard to copy everything from all the layers, Ctrl-V, then select Edit, Transform, flip horizontally, and just move it to the right side like so, like this. And you know, there are some stray pixels around here, so I can just draw those with the black color like this. Looking at my previous gauge, I believe I made the first and last tick mark a little bit bigger, which is of course just a matter of few clicks. So again, pencil tool, white color, and make this and this one a little bit bigger. Now let's merge everything into one layer by creating a new layer. Select Ctrl-A to select everything, Ctrl-Shift-C to copy everything, and Ctrl-V to paste everything. I can hide all of those other layers, and I can probably want to get rid of this black color, so I'll select the magic wand tool, which is this one. Make sure that the ferro is 0 pixels, tolerance is 0 pixels, and the continuous mode is disabled. I will select black color, get rid of this area, and Ctrl-D to deselect. Of course, I will need another background color, which is still here, but now I can move this around freely wherever I want this to be, and I think that just around here will be fine. Let's continue with the labels, and for that we need some kind of pixel font, so I'll go to dafont.com and select the pixel bitmap category, and I believe I was using the font which was called Pixelet, which is this one, so Pixelet by Omega PC777. So I'll open this font and click download to download the font. Unzip it somewhere on your hard drive, then go back to Photopea, select the text tool, open the font settings, and in here click the load font button, which will allow you to load any OpenType or TTF font from your computer. You can see I've already done this, so Pixelet is in here, so I'll select the Pixelet font and type in 0. Now for pixel font, it's important to set the correct font size, and the Dafont website is quite helpful because it shows you this size, so here it says it should be set to 10 pixels. However, for this particular font, if I change this to 10 pixels, you will see it's actually in the double size. So we should set it to 5 pixels instead, and make sure that the anti-aliasing method is set to none. This is fine, so I'll just move it to the right place and create a copy, again by either dragging this layer together with the Alt key pressed, or just by pressing Ctrl-J. I will double click this icon or somewhere around this text and type in a new number, which will be 10, or actually I will go with 20 this time, because I want to go this from 0 to 140 and continue like this. I'm using the arrow keys on my keyboard to move the layers by 1 pixel, and when editing the text I can accept the change by hitting Ctrl-Enter. Let's continue with the needle, specifically the needle center. For that I will reuse one of the older layers, which is this one, Gauge Outline Circle. I will create a copy, move this layer all the way to top, make sure it's on the right position, like so, and then select Edit Free Transform. Now usually this is in %, but I want to have this be in the size of 6 pixels, so I will delete everything and type in 6px for pixels, press the Tab key to jump to the next edit box, and hit the Enter key to approve this transformation. You can see it's barely visible because it's very thin, but that's perfectly fine because I will recreate this using the 1-bit color scheme. So create a new layer, and actually before I do so I will select the background layer and create a new color fill layer in the dark gray, because I want to create one layer that will be like a cover of the needle and then the outline of the needle. So for the cover, which is this layer, I will just select the pencil tool, set the black color and fill the pixels in the size of the center area. And then for the outline of the center area, I will create a new layer, set the white color, and again create the outline like so for the needle. For the needle itself, I will create a new layer, still have the pencil to select it, click anywhere around here, press the Shift key and draw a straight line like this. Then create a copy, move it 1 pixel to the right side and merge those two layers by selecting Layer Merge Layers. And of course move this below the center cover like so, and I can now hide this gray helper layer. Let's move to the right side of the screen where I will show the speed as a big number. For that I will copy one of the text layers, for example this one, so I'll drag it with the Alt key pressed and move it all the way to the top and change the label to say miles per hour, so mph like so, and then I will copy it one more time and say for example 70 miles per hour. I want a bigger font for this, so I need a different font because this one scaled up will not look very nice. Heading back to Dafont website, I've chosen this Aldo the Apache by AG Paglia. So again, I will click the download button, download it, unzip it and jump back to Photopea. In here select the type tool, open the font list and make sure to click the load font to load the TTF file. You can see already that it is loaded, so I will select the Aldo the Apache and increase the font size. Now you can go with whatever font size you want, but I did went with this font size of 39 pixels and and there is a reason for that, because I need all my images to be divisible by 8, so I just decided maybe I want this font, those individual letters, to be maximum of 16 pixels wide, which is exactly the case for the 39 pixel font. So you can see that the width is 16 pixels for individual digits. It might be even less for some of those. So I will just reposition it to be more in the center, both the MPH label and the 70 label, and I think that something like this looks nice. Now if I compare this to my previous creation, you can see that I also had these small tick marks outside of the gauge, so let's quickly add those as well. Hopefully I should still have the shape layers for the big tick marks, which are those two, so I will copy those two layers and put those on top, and of course move it to the right position, on the same position as the gauge, like so. And I want to merge those together, so Ctrl E to merge those, and I want to rotate those by a certain number of degrees. So I still have the calculator running with the degree for the big tick marks, so let's just say I want 4 tick marks in between, so I'll divide it by 4 and copy this value into the clipboard, then duplicate this layer, Ctrl J and Ctrl Alt T to transform, put the new angle, hit the enter key and repeat this process a few more times until it will be fully filled with tick marks. Like so. Now merge everything together, Ctrl E, and select the path select tool, select the big circles, like so, and those 3 tick marks which are not needed. And then I still need the outer circle, so I will borrow it from this layer. So select this one, copy into clipboard, hide it, and paste it in here. Of course, move it to the right position, because now it's offset to a different position, like this. And I want to scale it, but I don't see much. So what I will do is I will lower the opacity of this layer to maybe 20 or 30%. Then press Ctrl Alt T to scale it a little bit in a way that the tick marks are outside of the gauge, like so. And then I will select just the circle, so just this path, and again Ctrl Alt T and scale it back a little bit, just like this. And for this particular shape, I'll change the blending mode to intersect. I can increase the opacity back to 100%, and now we have a small tick marks. I think that's fine, so I will create a new threshold effect, so effect, new threshold effect, and I guess this is fine. Maybe if I want, I can make this circle a little bit smaller, so let's see if I can select just this circle and Ctrl T and scale it down just a tiny bit, maybe like so. And what's left to do is to manually adjusting the tick marks to always take 2 pixels, because this one only takes 1 and some of those take 3 pixels instead of 2. Same as the last time, I will create a new layer, then select the pencil tool, which is this one, make sure it's only 1 pixel, and make sure I have black and white colors for background and foreground, and I can press the X key on my keyboard to change between those. Maybe before I do anything else, I will move everything 1 pixel to the top, just so there is enough space, because I feel like I would need some space down here. I have speed up the playback because adjusting the small tick marks is really the same as adjusting the big tick marks, really just drawing black and white pixels to make it look nice. Also same as the last time, since the gauge is symmetrical, I can only work on 1/2, and then once I'm done, I will hide everything but the tick marks, select the left side of the tick marks, Ctrl Shift C and Ctrl V to paste it, move it to the right side, transform, flip horizontally, then create a new layer, again Ctrl A to select everything, Ctrl Shift C, copy it to clipboard, Ctrl V to paste it, and now we should have all the small tick marks in one layer. So just get rid of the black background by selecting the magic wand and deleting the black parts. So now we have this one, which are small tick marks, the speed, the center, needle, labels, and the big gauge. As a final step, let's just paste my logo and we can try to export this as a PNG file. So I'll select File, Export as a PNG file. This looks nice. The only difference I would make is I will make sure that the don't use plus is checked. Sometimes it's causing some problems, and just save it as a PNG file. Now, in order to display this image on Arduino, we need to first convert this PNG image into the C file. For that, I will use this image to CPP website, and I'll just drag this PNG image over the choose files, and I don't need to set anything special. I'll just click the generate code button. So I have the C file, and before I run this Arduino, I will use the WOKWI website, which is a free online Arduino emulator. And I will start with this progress bar example because it already has the OLED display. Animating a simple progress bar, this will be a great start for our project. Let's just do a few tweaks. So I will get rid of the progress, as well as increasing the progress, as well as drawing, string, and the frame and the box inside the drawing loop. And instead of this, I will draw a bitmap. So I will call this UAG draw bitmap, which I will copy from the UAG documentation. I will paste it in here. And I also need our image from the image to CPP website. So I will paste this here as well. And I actually don't need this array, so I will get rid of this array. I will only keep the image. I need to know the image name, which is this one. I have to use the very same name in the draw bitmap p function, and this requires x and y position, the width divided by 8, so 128 divided by 8, and the height of the bitmap, which is 64 pixels. So if I rerun the simulation, I should see our image displayed on the OLED display, which is exactly what I get, so that's great. Let's quickly try that also on the real Arduino. For that, let's start the Arduino IDE and paste our code. Make sure you have the right board selected. In my case, that's Arduino UNO, so it's this one. And right port selected. In my case, that's communication port number 7. If you have never used the UAG library before, you have to install it first. So you go to Sketch, Include Library, Manage Libraries. Wait for the dialog to appear and type in U8G. Scroll down a little bit, and this one U8G lib is the one we are looking for. You can see I already have this installed, but if you do not have it, you have to click the install button. If you are using the I2C version of the display, you don't have to change anything, just click this upload button. And hopefully you will see that there is no problem and that is done uploading. And here it is running on the Arduino. I've connected to different displays so you can see different colors. Looks nice, but it's still a static image and nothing is currently animating, so let's just fix this. For that, we need to first split our full screen image into individual pieces. So we will have the background of the gauge, the center part covering the needle, then the individual digits, the MPH label, and most likely my logo as well as a separate image. So what I will do is I will select everything except for the background and group this together and call this layers. Then duplicate this one more time and call this export. I will hide the layers, open the export and start putting the pieces together. And if I display the gray background instead of a black background, it will be easier for me to see what's going on. So I'll try to locate all the layers that belongs to the gauge background. So this is the gauge background outline, all the numbers and small tick marks, and I will just merge everything into one layer, Ctrl E, and this will be the gauge background. I will name it together with the -e prefix, and that will basically tell Photopea that I want to export this layer later on. So I'll call this gauge PG, gauge background, and I also need to have this together with the black background. So what I can do is I can select everything for that layer and also make sure that my selection is divisible by 8, so 60, 70, 72 is actually divisible by 8, so 72 by 64. Then I'll select Edit, Fill, and I want to fill this with a black color, and I want to use a blending mode. For example, I think that I will go with color burn. That should keep the white areas intact. Click OK button, and now I have the image ready to be exported. So the next step will be the covering piece of the needle, which is this one, and I believe this one is like 6 by 6, so I will export this by 8 by 8, and I want this to be in an inverse color because I will basically draw this as a black, but I need to have those pixels as white. So I will first invert it, so Ctrl I to invert, then select Edit, Fill, the same settings, and name this -e center fill, and I'll do the similar thing with the center outline. So Edit, Fill with the black color, and name this -e center outline. And a nice thing to do when you are doing those kinds of stuff is you can use layer colors to identify, for example, which layers I already have ready to be exported. So I'll right click and select color and maybe choose purple for my case. My logo, well, I believe will be like 16 pixels wide, so I'll fill it with black color and call this -op logo, set the color. Then we have the MPH label, and this one I believe can fit into 16 pixels as well, which is great. But if I select Edit Fill, you will see a warning message saying DEX layers must be rasterized first. So I'll right click and select Rasterize, and then I can select Edit, Fill, and fill it with black color. Again, -e MPH label, and that should be it for the gauge. So the only missing piece are the individual digits. So I have this example speed label, which I will copy and change the value to be 0 and make sure that the text is center aligned. Just because I want all the digits to be maximum of 16 pixels wide, I will create a new selection that will be 16 pixels wide, and I will actually create a new layer and fill this layer with black color. So now when I create other digits, I can see if this digit will fit or not. So I'll copy it, Ctrl J, and of course double click and change it to digit 1 and continue like this with all the other numbers. Now you can see that the digit 4 doesn't fit, and we have few choices. We can make the font a little bit smaller, we can go with the wider letters, so instead of 16 it will be 24, or we can just slightly adjust the digit, which is something I will do. I will just get rid of those pixels. So I will copy this first for number 5, but before I do so, I will create this selection and create a new mask for this layer. So clicking this icon will create a new mask, so now it doesn't go outside of our area, and continue with other digits, and hopefully the other ones will fit. And thankfully that was the case. The next step is to rasterize all the individual text layers, apply the layer mask for the number 4, and fill the background for the individual letters. I'm speeding this up a little bit just because I've already shown you how to do this. I'm also changing the layer names to include the -e- layer prefix to make sure that the Photopea will then later on export those layers. There are also some layers that I don't need anymore, so I'm deleting those. As a next step, let's just move the gauge together with the center part 1 pixel to left, so we have more space to the digits on the right side, and I think that looks nice for our Photopea part, so let's just export those layers by clicking File, Export Layers. In this dialog, you can see it says we will have 15 exportable layers because we are only exporting layers which starts with the name -e-, and I think that I will click don't use palette because sometimes it causes some problems. Clicking, PNG format is fine, 100% quality is fine, everything else should be set to default values. So I'll click export layers and it will export me the zip file which includes all the PNG files. And so here we have everything that we need, so the center fill and outline, all the digits, gauge background, the MPH label and my logo. So I will extract those files and jump to the image to CPP website. In here I will generate code for all the images except for the digits. So for those 5 images, I will click the generate code and copy the code into our WOKWI sketch. And I don't need this full screen image anymore, so I will delete the code for the full screen image and instead paste those 5 images. I don't need array for those images, so I'll delete this array as well. And the next step will be drawing those individual 5 images. So 1, 2, 3, 4, 5. And I will speed this up a little bit, but I will copy the names like so. So this is the first one, is center fill. And I of course need the size, so this is 8 by 8. So I'll change the size to 8 by 8. And I will continue like this with all the other images. Once this is done, I need to get the right positions because 0, 0 is not a valid position for all the images. So what I can do is I can jump back to Photopea, select any layer and click this distances checkbox. And it will show me the distances from all the sides. I'm only interested from the left side, which is 28 pixels, and from the top edge, which is 60 pixels for this logo. So in the same way, I will change all the other positions. So let's see what we get if I click this rerun button, so restart the simulation. And it's just slightly wrong. You can see that this middle piece is white, it should be black. So I think we want to first draw the background of the gauge. Then we want to draw the center fill, but the center fill should be drawn in a black color. So I'll change the set color index to 0, which is a black color. And then I will change it back to white for the outline, so this is white, and that should fix it. Let's add the potentiometer to set the speed value before we get some real data, and I will do this by stopping the simulation, clicking the plus sign and typing potentiometer. Like so, I will place it next to the OLED display and of course connect the ground to the ground, which is this black wire, and then connect the VCC to 5 volts, same as the display, so for example here, and finally connect the signal to one of those analog inputs. So I will most likely go with a 0, so I just try to place it just around here so it's not touching our wires, and maybe change this color to, I don't know, maybe pink is fine. So if I open the documentation for potentiometer, you can see there is a sample code in here. So in the setup function, I will set the pin mode to input, and they are also using A0, so I don't have to change anything. So inside the setup, set the A0 to input, and then read the value inside the loop function. So this is the analog read A0. So I'll copy this over the UHG drawing loop, so for the main loop, and I will create a new variable which I'll call speed, so integer speed, and let's just set it to 0 for the initialization, and then say that the speed equals analog read 80. Now this goes between the 0 and 1023, so I'll map it to some reasonable range. So I'll say that I want to map this value which originally goes from 0 to 1023, and I want to map it between 0 and, for example, 140 miles per hour. That should be fine. And I want to of course print this value inside the loop function. For that I will use the UHG draw string, so I'll copy this code into my code. So I want to draw the string, and I want to of course draw the speed string, but if I do it like this, I will get an error because this function, the draw string, expects the C style string, not an integer. So for this I need to first convert this integer speed into the C style string. So I need another variable which will be an array of characters. So let's just say character speed string, and we need to specify how many characters there will be. I think that we are fine if we go up to, for example, 10 characters. And the final step is to convert, of course, the speed into the speed string. And for that, we will use the function I to A, which is exactly for this case. And And here's an example. So I2A, some number into the buffer, and the 10 stands for decimal number. So I'll just copy this into our code in here before we draw anything. I will call I2A, our integer is speed, and our buffer is called speed string. And of course we want to use decimal value. So I will, instead of drawing the string speed, I want to draw the speed string just like so, and maybe move it more to the right side. So for example, x90, y20 should be fine. Let's rerun the simulation and see what we get. So if I zoom in a little bit, you can see that as I turn the potentiometer, I'm changing the value between values 0 and 140. Let's try this version also on the Arduino. The first step is same as the last time, just paste our updated code and hit the upload button. And here it is running, and it's not changing the value because I don't have the potentiometer connected. But before I do so, let's talk about the displays. So here I have two displays which are different in size, but the actual resolution is the same, as well as the used chip, which is SSD1306. The main difference is number of pins. So this one has 7 pins and it's pre-configured to use the SPI connection. The other one has 4 pins and it's pre-configured to use the I2C connection. The UADG library supports both connections, but keep in mind that while the I2C connection is much easier to connect, the SPI connection will be faster. Again, I've created this custom PCB on PCBWay, and I've tried to draw the connection between the Arduino pins and the display pins for both the SPI and I2C connections in 2 different orientations. You can as well use this prototyping shield with breadboard wires, and you can see I already have this potentiometer connected, so I'll just connect the SPI version of the display like so. And when I snap it to Arduino, nothing will actually show because we have to change our code to properly initialize the SPI connection of the display. And if you are using the same pins as I do, it should look like this. And after uploading, there should be a value displayed on the display, and if you turn the potentiometer around, the value should be changing. So we just need to display this number with big digits. So let's go to the image to CPP website, choose the images for digits from 0 to 9. This is how they look like, and just click the generate code and get the C code for those digits. Paste this code into the Arduino WOKWI sketch, and this time I will actually keep the array, and it will be quite helpful because now we can draw the image based on this array, so it will draw bitmap digits from 0 to 9. So let's just try it. So inside drawing, I will copy the draw bitmap p function, and we just quickly need to know the position. So in Photopea, let's remember that the x position is 74 and the y is 16. So 74 for x and 16 for y. The size is 16 by 28, and we will not call bitmap digits and number, will instead use this array. So I'll copy this array, and for the index, let's for example use the speed modulo 10. That will give us the last number. Let's just close the bracket and rerun the simulation. And you can see that now as I turn the potentiometer, I always get the last number from the digit, which is nice, but I want to do something different today. I don't want to do any calculations for the speed value because I already have this speed string. And if you think about it, the speed string is just an array of characters, and the character is really just a number from 0 to 255. So what I can do is I can use the speed string to draw some of the image. So for the index for the bitmap all array, I will actually use speed string, and let's just say I want to use the first character that will have a number from 0 to 255, but I know it's a number from 0 to 10. And if I look at the ASCII table, a character from 0 to 9 actually corresponds to the decimal value of 48 through 57. So what I need to do is I need to subtract the number 48 from the character value. Inside here, I will subtract the value of 48, and hopefully if I re-enter simulation, I will get the first number from our string, which seems to be the case. So you can see that now I draw the first number, and I can continue like this with the other numbers. So 0 is the first digit, 1 will be the second digit, and 2 will be the third digit. So I'll put everything inside the loop, and for this I need to know how long our string is. So I create a new integer variable that I will simply call speed string length. And before doing anything, and I want to actually calculate the length, so I will use a function called strlen, which only requires one parameter, and that is the speed string. So I know how long this string is. Let's create a simple for loop to loop through all the individual letters. And for the actual character, we want to use the value of y, and we want to also increase the x value. So let's say it's 74 plus, and the width of the character, which will be 16 plus some kind of space, so maybe 18 times y. And let's see how this looks like. And it's kind of overlaid over this string, so which we don't need anymore, so I can comment this out to see the numbers better. And I like how this looks like, although I would probably prefer if those numbers would be center aligned, so if there is only one number, it will be in the center. Same with two numbers, and the three numbers will have this position. Let's see how this looks like in Photopea. So I have this center position, which will be the center for our string, and if I only have one digit displayed, it will be the center position minus half of the width of the digit, which is of course 8 pixels. If I have two digits displayed, it will be center minus 2 times half of the digit, which is 16, and if I have 3 digits, it will be center minus 3 times the half of the digit. So let's try to put this down as an equation. So again, the x position will be the center, which is 99 in my case, minus the number of digits, which is speed string length, times 8, which is the half of the digit. We still want to add the 18 times y for individual digits. So let's see how this looks like. And if I lower the value, you should see the numbers being center aligned. So that's great. Here it is running on the Arduino, and as you can see, it looks much better now with the big digits. Just a side note, you could use a proper UHG font instead of just images, but if you would use these big letters, it will take a lot of memory and might not even fit on Arduino. I've made one small change, and that is I've created this variable speed string start position, and I calculated outside this for loop. So previously it was calculated in here, now I have a separate variable. And the reason for this is that the UHG library updates the display by pages, and one page is 8 pixels tall, so for this particular display, which is 64 pixels tall, we need 8 different pages, which means that this loop actually repeats 8 times. So any calculations that we can move outside this loop, so here I have this new calculation, will speed up the performance. At this point, the only missing piece is the needle, and for that we don't need any special images except for what we already have, that is the center part, because the needle will be drawn with the draw line function, which is this function. It only requires the starting position and the ending position, but we first need to calculate those points. For that we will use the polar coordinate system, where we don't define the point with the x and y values like we usually do, that's called the Cartesian coordinate system, but we define the point with the radius r and the angle. If you look at this blue line, it's very similar to our needle, where the needle also have some kind of radius or length that is not changing. We are only changing the angle, we are only rotating the needle. And so once we define this point with the radius and the angle, we want to draw it, so for that we need to convert it to Cartesian coordinate system, and this is this calculation. So we will convert it by saying x equals radius times the cosine of the angle, and y equals radius times sine of the angle, and you will get something like this. So if you want to have the 0 position on a different position, or maybe clockwise instead of counterclockwise, we will just switch the cosine and sine, or maybe perhaps change the sign from plus to minus, but you will see that in a minute. For now, let's start by creating a few new variables. We need the angle of the needle, preferably in degrees, and then we need the start position for x and y and the end position for x and y. And in addition, we also need the center position for our needle. The center position of the needle will not be changing, and we want to get the position of this point. So if I measure this using the rectangular selection, I get values 35 for x and 36 for y. Let's use those in our code, so 35 and 36. As for the x and y values, let's calculate the start position first. So I will say needle start x equals something, and that something is of course the calculation that we've already seen, which is the radius times cosine of the angle. And it might be a good idea to create a new variable for this. And let's set it, for example, to 30 pixels. So it will be radius times sine or cosine, and I already know that I want to use minus sign to get my proper angles. And in here we want to enter the angle, which is the angle, needle angle degrees, but that has to be first converted to radians. So I'll say radians of this angle, and that should be hopefully fine. I will do the same thing for the y position, except I will change this to plus cosine. With those 2 points defined, we can try to draw a line inside the drawing loop. So I'll just copy this piece, which is the UHG draw line, and I want to draw the line before I actually draw the centerpiece of the gauge. So after drawing the gauge background image, I will say UHG draw line, and for now let's draw it from the center, so center x and center y, to the start position x and start position y. If I rerun the simulation, something wrong will probably be displayed, and the reason for this is these calculations are for rotation around the origin, around the point 0, 0, and in our case the needle is not positioned on the position 0, 0, so we need to offset it by the center position. So we want to say plus center x and plus center y. Rerun the simulation and hopefully we'll see something better looking, which we do. So I don't know if you can see it, but we have the needle in the 45-degree position, which is the starting position for our needle. If you look at our Photopea file, the needle actually goes not only to the center, but it continues a little bit down to the other side as well. So let's just fix this. We will need another variable, and this time let's call this integer needle radius small. And obviously let's go with some smaller number, for example 10 pixels. Then I'll copy those two lines, and instead of calculating needle start X and Y, I will calculate needle end X and needle end Y. We also want to use the needle radius small, and we want to draw it on the other side, which means that the angle should be increased by 180 degrees to be on the other side. And then we need to change the drawing function, so in the draw line we don't draw it from the center, but we actually draw it from the start to the needle's end X and needle end Y. Like so, and let's rerun the simulation. So now the needle goes outside and the image is covering few of the pixels in the center of the needle. However, the needle is still static and not moving with the value. For that we want to calculate the needle angle degrees value before we actually start drawing or start calculating the positions. So we'll say that this value equals, and it will be in some kind of relationship with the speed value. So we want to map the speed value, which goes from 0 to 140, and we want to map it from the angle of 45, which is the starting angle, to the angle of 270 plus 45. Obviously you can just type in 315, but this is more obvious. And this one line should be all that's required to move the needle around. So let's try that, and you can see that the needle is indeed moving. The very last step is to make the needle 2 pixels wide, and since there is no simple function to draw border lines in the UIG library, we have to do it by ourselves. And the technique that I come up with is very simple, so we just draw a second line that is slightly offsetted, and the offset is based on the angle. So if the slope of the needle is somehow around here, more of the vertical needle, we will move it on x-axis. If it's more around here or here, that is the needle is more of the horizontal, we will move the second line in the y-axis. We need two new variables, the needle offset x and needle offset y. And we want to set those variables based on the slope. So I can create a new if statement, and I will say that if the angle is bigger than 45 and at the same time the angle is smaller than 135, or if the angle is actually bigger than 225 and smaller than 315, this means that this line is more of a horizontal line, which means that we don't want to offset by x and we want to offset by y by 1 pixel. If that's not true, this means that the line is more vertical, and for the vertical line we want to offset by x by 1 and not offset by y. So let's draw a second line with those parameters. So I will copy the draw line function one more time, use the same values, but I will of course offset x by x, so x plus x, and this end plus x, and I will offset y by y, so start plus offset y and end plus offset y, and see what we get. And what we get is an error because I did forgot to insert brackets for this statement, so this should be inside brackets. Hopefully this will work now. And really we get a line that looks like it's 2 pixels wide. As a final tweak, I have increased the needle center X value to 36 because the needle was touching the left side and there was 2 pixel gap on the right side. I think now it looks much better. So this is the final version of one simple gauge running on the Arduino UNO with the OLED display, right now being driven by the potentiometer, but stay tuned for the next video where I will change this to some real data. If you have any questions or feedback, please put those down in the comment section below the video, where you can also find some useful links, and I hope to see you next time. Thank you for watching and bye.